All right. Welcome back, everyone, to Fabric Quality Control Full Analysis. I'm your host, QA Jamae. In the first half, Ned gave us a deep dive into the principles, equipment, and operating procedures of flatbed printing, which was incredibly insightful. Now, we're going to continue by exploring another giant in traditional printing, rotary screen printing. Ned, I hear it's the speed champion of the printing world?
That's right, Jamae. Rotary screen printing is the epitome of continuous, high-speed production. If flatbed printing is precise segmented work, then rotary screen printing is assembly line work, aiming for maximum efficiency. It's also known by the nickname rotary printing.
I heard its principle is similar to flatbed printing, but what's the main difference?
You're very perceptive, Jamae. The principle of rotary screen printing can be considered an evolution of flatbed printing. It transforms the original flat nylon screen into individual cylindrical screens made by etching on metal nickel mesh. These cylindrical screens are hollow inside, so the biggest difference after plate making is that the screen is rolled into a cylindrical shape. Now, let's visualize this. The fabric moves continuously forward on a conveyor belt below. Above the fabric, there are rows of cylindrical screens rotating in sync. Inside each cylindrical screen, there's print paste which is forced out onto the continuously moving fabric below through the pressure of an internal squeegee, passing through the pre-etched open pattern areas on the screen. Because both the screen and the fabric are in continuous motion, it achieves extremely high production speeds.
Wow, it sounds like a super large printer, and it's rotary. So if it's made into a cylindrical screen, doesn't that limit the pattern's repeat?
That's right, Jamae. Its fixed length is typically 64 centimeters, which is similar to the repeat limitation of flatbed printing. Because the rotary screen is cylindrical, continuous printing relies on the screen rolling over the fabric. Therefore, the repeat issue must be considered to ensure the pattern's continuity in the warp direction. The rotary screen's repeat length is fixed, usually 64 centimeters or its equal divisors. But rotary printing is indeed the fastest printing method among all. Typical production speeds can reach 20 to 50 yards per minute.
Wow, that's up to 3,000 yards per hour at its fastest. But does it also require the steaming and washing process like flatbed printing?
Just like flatbed printing, once the printing is complete, the fabric also needs to go through drying, washing, and setting to become the final product.
What are the advantages and disadvantages of rotary screen printing then? Does it also involve plate making costs?
Yes, rotary screen printing certainly has its advantages, such as its high production speed. And for some patterns that are not well suited for flatbed printing, like stripes, rotary screen printing can produce them effectively. Furthermore, due to the continuous nature of production, there is no issue with repeat line. Conversely, its disadvantages are similar to flatbed printing, meaning it requires plate making. If the order doesn't meet the printing factory's MOQ, or minimum order quantity, additional charges may apply for machine setup and plate making fees. Additionally, since rotary screens often use metal nickel mesh with relatively larger mesh openings, the lines printed on the fabric tend to appear coarser. At the same time, excessively small details in the pattern can easily blur due to bleeding. Therefore, rotary screen printing is more suitable for printing bold or large area patterns and not for intricate designs with very fine lines, dots, or cloud patterns.
Hearing your detailed explanation, I now have a much clearer understanding of how flatbed and rotary screen printing work, along with their pros and cons. Although these two traditional printing methods have limitations in plate making costs and pattern repeats, their advantages in large-scale production, where volume and speed are crucial, are still quite significant due to their mature processes. Ned, thank you so much for explaining these complex technical concepts so clearly. Hello, everyone, and welcome back to our podcast series, Full Analysis of Fabric Quality Control. I'm your host, Jamae. After our discussion with Ned about production equipment, we are now joined by our experienced quality control expert, Alan. He's here to help us diagnose issues by looking at a series of defect photos. Welcome, Alan.
Hello, Jermaine. It's a pleasure to be here and talk about textile printing quality management.
Alan, before the recording, we compiled several defect photos sent to us by QC teams from various suppliers. Now, I'll show you these photos one by one, and I'd like you, as our inspection master, to diagnose the defects and explain their possible causes. We might not be able to cover every single defect today, but I believe our discussion will be helpful for all our listeners.
No problem. I'm ready for the challenge. We can also hold a special class to explain these types of fabric defects in detail.
Excellent. Let's look at the first photo. This one shows a camouflage pattern printed in blue, green, and brown, but the area indicated by the arrow has a greenish tint, and the color seems to have spread. Is this what happens when the pigment spreads beyond the design's boundaries during printing? Does this look like bleeding?
Yes, Jermaine, your assessment is spot on. The photo clearly shows a printing defect known as bleeding or blurred edges/spreading.
So what causes this bleeding phenomenon?
There are many reasons for bleeding, ranging from the print paste itself to the printing process. First, let's look at this photo of a red and black checkered fabric. Doesn't this area look particularly uneven? This could be due to insufficient paste viscosity or poor penetration. Print pastes have thickeners added to them to prevent colors from spreading, but if the proportion of the thickener is incorrect, the paste flows like water, blurring the edges. Second, from an operational perspective, if the pressure of the printing plate and squeegee is uneven, or if the tension on the left and right sides of the squeegee is not balanced during operation, it can cause the amount of paste applied to exceed or fall short of the average, leading to color bleeding. Next, I have another photo. After flatbed and rotary printing, the fabric needs to be steamed and washed, but if the printed fabric is stacked for too long, the moisture can cause the wet paste to spread outwards. Finally, the fabric's properties can also play a role, as loosely woven or thin fabrics or hydrophobic synthetic fibers are more prone to bleeding.
I see. So this is a complex issue involving both material science and operational techniques. Let's move on to the second photo. This one shows a folk-style striped print, and we can see a whole row of white dots at the marked spot. The colors were supposed to be joined tightly, but the fabric's base color is showing in between, as if they didn't align. Is this a misregistered print?
Excellent observation. This is a classic misregistration or off-register defect.
Misregistration sounds very technical. Could you explain it?
Misregistration occurs when two or more colors in a pattern do not join together according to the original design, causing a displacement or exposing the unprinted fabric base. In other words, when printing a multicolor pattern, if the different screens or printing positions are not precisely aligned, it can cause the edges to be displaced or overlapped or expose the fabric's base color.
I see. So this is a complex issue involving both material science and operational techniques. Let's move on to the next photo. This one shows a printed fabric with strange white dots in some areas, as if the ink didn't get printed at all, revealing the base fabric. Is this what's called a misprint?
Exactly. This can be called a misprint or missing print. A missing print refers to an area of the printed fabric where the color or pattern has not been printed. The most common cause is abnormalities or foreign objects on the fabric's surface. Imagine if there's lint or some other foreign object on the fabric's surface, the pigment might be printed on it. Once that object falls off, it leaves an uncolored area, causing a missing print. This is particularly common in cotton fabrics or those with a lot of fuzz, and the defects are usually irregular.
Oh, so even lint can be a culprit.
Correct. That's why fabric pre-treatment is so important. Some fabric mills use a singeing machine for pre-treatment of the fabric to prevent this. A second cause is fabric wrinkles. If the fabric is not laid flat on the printing machine and gets wrinkled, the print paste can't be applied to the inside of the folds, leading to a missing print. This defect is more common near the fabric's edges.
I see. So if a missing print occurs, how do fabric mills usually handle it? Can it be repaired?
If it's a pinpoint missing print, it can sometimes be repaired by manual spot coloring. However, this repair method comes with high risks.
What kind of risks?
There are three main risks. First, color variation. It's difficult to perfectly match the color used for spot coloring with the mass-produced color, especially for fluorescent shades, so the repaired spot might turn into a colored dot. Second, stains from wet pigment. The repair pigment might not dry completely and could stain other areas. Third, bleeding through the back, where the repaired color might seep through to the back of the fabric, leaving a mark. Therefore, the best solution is prevention through enhanced fabric inspection and equipment maintenance before production.
Let's look at this next photo. The color of this printed fabric appears uneven, with some areas darker and some areas lighter in the left, middle, and right sections. What's going on here?
This is uneven color shade or streaks. This defect is usually caused by inconsistent squeegee operation during the printing process.
What specific operational issues lead to this?
Well, if the squeegee's speed or pressure is uneven, it leads to uneven paste application, causing the fabric to absorb different amounts of paste. This can lead to regular color variations from left to right or center. Also, specifically for flatbed printing, if the screen lifts and reapplies to the fabric without proper adjustment, it can leave a darker horizontal streak. Sometimes, the back of the fabric will also show a clear joint mark from this.
Let's look at one more photo. This one shows a repeating pattern, but I can see a thin, subtle line between the patterns, as if it's where different printing plates connect. Is this what's called a joint mark?
Jamae, that's a very sharp observation. This indeed is a joint mark, or connection trace. This defect is common in traditional screen printing.
So how is this joint mark created?
The main reason for joint marks is that traditional printing relies on repeating repeats to print continuous patterns. Flatbed printing, in particular, requires one screen after another to connect the print. When the connection points of two printing plates or rollers are not perfectly aligned, or if the paste is not evenly applied at the joint, it can leave a trace or a line.
It sounds a bit like a puzzle that hasn't been put together properly, leaving a gap in between.
Exactly. That's the concept. In flatbed printing, after the squeegee performs the printing action in the weft direction, the screen lifts and lowers, and the fabric then moves forward to the next printing position. If this movement and positioning are not precise, a joint mark can be created.
Alan, your explanations really show how interconnected every step of the printing process is and how crucial it is to pay attention to every detail. Thank you so much for your expert analysis today. I hope our listeners have learned a valuable lesson and can become masters themselves when inspecting defective fabric. See you in the next episode.